Hey students, in this video I'm going to introduce you to how we can use the elimination method for solving systems that are 3 by 3. However, this is a long process, so we are going to have 2 videos at least. So this is just part 1, introducing you to what elimination method is in general, and then what augmented matrices are. And then in part 2, you're going to see the process of elimination method. Okay, so what I explained in class is that we need to understand what the word eliminate means. And we clarify that eliminate just means to cancel out, to make things zero. So I just want you to remember that. And what this means visually is that if we have an integer like -3, in order to eliminate -3, we will have to add 3. So inverse operations come in hand. However, we are just eliminating. So if you have a positive or negative, we are either going to add or subtract to eliminate. Both of these give us 0 if we add downwards, and that's how they cancel out. So this is what eliminate means. After this, I explained how elimination method is used in Algebra 1 level. That way you can get familiar with the steps for elimination method. So for example, if you had an equation or system of equations that look like this, 2x plus 3y equals 20, and -2x plus y equals 4, we mentioned that these are easy to eliminate because you already have the same number and you have a positive and a negative. So right away, these are going to cancel. To make this video go faster, I'm just going to show you an example of where this is not happening. That way you can also see what to do when you don't have the same number. So for example, let's say we have 3x minus 4y equals -5, and then 5x minus 2y equals -6. So these are both, like I said, systems of equations. However, this one on the left side can be eliminated easily and solve for y. And with the y, you can substitute and find x. But here, when we don't have the same number, we have to convert. So this is where you have to ask yourself, which one will do the elimination and conversion with less steps, which is the least amount of steps you can take. So we talked about how these x's can become a number that they both can cancel. For example, 3 and 5 can become a 15, but one of them has to be a positive 15 and negative 15. So we will have to multiply both of these numbers to be able to cancel them. Over here in the y's, we talked about how 4 and 2, the 2 can become a 4, and the 4 can just stay. So in this example, we will just have to multiply the bottom equation. So the one with the least steps is most likely that one if we focus on converting this -2 into a positive 2. I'm sorry, a positive 4, so it can cancel that. And the way we're going to do that is multiplying -2 times -2. That will give you that positive 4. So let's just focus on this part. We are going to rewrite a new version of this system. The top equation wouldn't do anything with that, so we're just going to write it. And the bottom equation, we are going to write the new version after we multiply or distribute this -2 into each part of the equation. So we're going to have -10x plus 4y equals 12. So now we have created a system of equations where we can add downwards, and that eliminates the y's in the middle. Positive 4, -4 cancel. And we have 3 plus -10, that gives you -7x. -5 plus 12, that gives you positive 7. And then here we just solve for x. So we divide both by -7. So x equals -1. And by finding this answer, we go back to asking ourselves, we are not done, because if you notice, the equations are two variables, two unknowns, and so far we only found one of them, x. So now we need to find the y. And again, this is the part where it doesn't matter which original equation you choose, you just gotta pick one in order for you to use and solve for y. So we're just gonna use the top one, 3x minus 4y equals negative 5. And we're going to replace this x value with negative 1, because that's the value we found. So now we have this equation. And when we have this equation, you technically are just solving for y here. So now every time there's parentheses, we look at the coefficient and distribute that. So 3 times negative 1, that's negative 3. And then after this, we are keeping the y, or the y term. So we're going to cancel the constant. So we're going to add 3 to cancel or eliminate. And now we have negative 4y equals negative 2. And the last step will be to divide by negative 4 both sides. So y equals positive 1/2. And that is your y value for the solution to the system. So here we're going to have positive 1/2 as the y value in the solution. Again, this is just algebra 1 level. This is elimination method. So it was just kind of a review to help you remember the steps. After this, we talked about what algebra 2 is going to ask you to know. So algebra 2 level is going to ask you to know what an augmented matrix is, or to convert systems of equations into augmented matrices. So to remind you what an augmented matrix is technically only looking at the coefficients and constants. So I'm going to show you an example of a 3x3 or a algebra 2 level system of equations. And then we gotta notice here that when we write the matrix for this system, it has to follow a pattern. So I'm going to color coordinate the coefficients first, that way you understand what coefficients are. Coefficients are the numbers in front of the variable, attached to the variable. So what I'm highlighting in green, or in this bold color, it's the coefficients. So this means that, notice I didn't put any of the letters or pluses, because when there's a number by itself, we are to assume that it is positive. We are also going to need to write the constants. So let me write those vocabulary words, constants and coefficients. And the matrix is going to look like this. Okay, first equation, written in just numbers, no letters, no equal sign, no plus. The order that we're writing is in the form of x, y, z, and then the constant at the end. So if we replicate that pattern, this negative 4 has an x, so we're going to put that negative 4 in the front. There is no y value here, so we're going to say that there is no y value, and the way we show that mathematically is just putting a 0. Here we have a 2 next to the z, and then a negative 2 for the constant. On this last equation, there is no x, so we're going to put a 0 for the x, and then there's a negative 2 for the y, and then negative 4, and then a 1. So this right here is the augmented matrix. Sometimes you're going to see a vertical line in the matrix, and that just simply represents the equal sign. But sometimes you're not. So just understand that the constants are always on the right side and the variables are on the left side. One thing that's going to happen sometimes is that you're not going to have the equations in order. So you're going to have to just rewrite them in order for them to be in that order. So I'm just going to show you an example. If they are out of order, for example, here I would have 5x equals negative 2z plus 9. 3x minus 8z equals negative 5y plus 15. And 4x plus 2y plus 9z equals 10. So these are not in the same order you see on this example because all of the variables on the left side, constants are on the right. So you can either rewrite this or rewrite it as you write your matrix. Some people can just look at this and know that the z needs to be moved on the left side. So if we write the order of x, y, z and the constant, x is going to go right here. There is no y, so it's a 0. And this negative 2, like I said, doesn't belong on the right side, it belongs on the left side. So if we're going to move it to the left side, that means we're going to eliminate it on the right side by adding 2. So if we add 2, that means we're going to end up with a positive 2. And then a constant of 9. If you are visual, just go ahead and rewrite this system first in the correct format. So I will write 5x plus 2z equals 9. And then the next one will be 3x followed by the y. The y is right here on the other side that it shouldn't be. So we're going to eliminate that by adding 5y on both sides. So plus 5y and then minus 8z equals 15. And then the last part is already in order. So this is more of an organized format, and we're just going to write those numbers in our matrix. Okay, and that is all we did today. We just learned how to write augmented matrices for Algebra 2 level. Part 2 is next.